Okay, we have a few easier ones, numbers 12, 13, and 14. Let's see if we can fit all three onto this recording. First one, 5 is equal to negative x minus 3. So they're going to have negative x, which we don't like. We don't like to have a negative x. And usually we're solving for x. And if you'll notice over here, it says what's x equal to, not what negative x is equal to. So we have to be sure to change the sign. And there's a pretty easy way to do that. We'll do it first. We're going to add a positive x to both sides. Got to be thinking creatively to get rid of the x and move it to the right side. And we'll add an x, oops, hey, this thing has a mind of its own, plus x. Okay, so these two cancel each other out, and that leaves 5 plus x on this side. That's equal to negative 3. And so what we're going to do next, change the ink color, and we're going to remove 5 from this side, and that means taking 5 away on this side also. These two disappear, and then negative 3 minus 5, we've got, if you think of the negative sign as like a form of a unit, you've got two negative things coming together, there's going to be more negativity. So combine the 3 with the 5 to get 8, but it's negative. And x equals 8, x equals negative 8. So our answer in here would be negative 8. And you just have to remember, it can be tricky when they use those signs, but if we substitute that number in, let's use, if we put this negative 8 up here in the x, then we can work it. 5 is equal to, now, x is equal to negative 8, but this is negative x, so we have to write negative, right? And then negative 8 is our x value, and then minus 3. So because you've got this tricky double negative, we can distribute this negative sign over this. That means just negative times a negative, you get positive. That means it's a positive 8 minus 3, and that is equal to 5. This is just 8 minus 3, which is 5. 5 is equal to 5. We're golden. Okay, let's look at the next one. Number 13. 6 is equal to negative 3x minus 4. All right, and so we're solving for x. So again, this is a negative 3x, so we want that on the other side. So let's start by adding 3x to both sides. This side, these get canceled out, and we have, you could write, that's a positive 6, so you could write 3x plus 6, or 6 plus 3x, doesn't matter. In multiplication and addition, it doesn't matter which way you set them up. And then we've got that's equal to negative 4. Okay, so next step is to get rid of the clutter around the x, and we're going to start with this peripheral 6. We're going to take it away with a negative 6. We got negative 4 minus 6. These are both negative. Let's combine them for negative 10, and that's equal to 3x. 3x is equal to negative 10. Next thing we have to do, what's happening to x? It's being multiplied by 3. So we're going to divide by 3 on both sides. That leaves x. X is equal to negative 10 over 3. And that won't reduce, so we can leave it that way. That's our answer. So we can plug that in up here and see if it works. Is 6 equal to negative 3 times negative 10 over 3? So you have to keep those together. This is a negative. The positive x is negative. So wherever the x is, that you just substitute that in just like that, minus 4. And so 6 is equal to this. Negative 3 times negative 10 over 3. This is a negative times a negative, so these 3's will cancel each other out, leaving positive 10 and minus 4. And is that equal to 6? I believe it is. 6 is equal to 6. So that is a good answer. Look at us, we're really rolling. So this is negative 10 slash 3, and we'll move to the next one. See if we can do a record-breaking 3. I haven't done 3 on the same one since the first recording. All right, x over 7 plus 5 is equal to 2. All right, so they're complicating it a little bit by making x a fraction, but we're going to go ahead. I'm liking that x is already on the right, so let's take a look at that 5. What are we going to do? 5 is being added to the x and we're going to take 5 away. So these two cancel out, leaving x over 7. And 2 minus 5, the signs are different, positive 2, negative 5. So we're going to take the difference between the numbers, which is 3, and the bigger number 5 is the one with the negative sign, so the negative sign survives on the 3. So x over 7 is equal to negative 3. X now, this hasn't happened very often, but you just have to be ready to roll with it when it does. X is being divided by 7. So to counteract that, we're going to multiply by 7. But we have to multiply both sides. So 7 times x over 7, you're going to get 7x over 7, which is going to turn into 1x, or x. And that's equal to negative 3 times 7, which is negative 21. So here's our answer. This was very quick. And if we plug negative 21 over 7 plus 5 is equal to 2, right? So that's what we should get. This is our x value, and positive x value is a negative number, so we just have to put that in there. So we can reduce this. 21 is divisible by 3, so we've got negative 20, and it's also divisible by 7. Negative 21 divided by 7 is negative 3 over 1, which is equal to negative 3 plus 5. And now is that equal to 2? Let's see, negative 3 and 5, positive 5, negative 3. Signs are different, so the difference between those two numbers is 2. And the bigger number, 5, has a positive sign, so I think we're good. There, we did it. 3 in just over 5 minutes. Let's add one more bonus round, number 15. We'll try this. This will be a little bit longer. 5/6x. That was just a little fun. Plus 5/12. It's hard enough to even say these numbers. Is equal to 1/18. Okay. So what is x equal to? So you know the drill by now. Should be getting better at these. Are you feeling more confident? We're going to subtract 5/12 from both sides, right? So on this side, these go away, and we have 5/6 x is equal to this. So in order to subtract 5/12 from 1/18, we have to find a denominator that we can use, and we usually use the LCM method, least common multiple, and that means we do a different color. We're going to do a prime factorization of 12. So we divide by the lowest primes. The low primes are 2, 3, 5, 7, 11. And those will get most of your job done. 2 goes into 12 6 times, and then 6, we can divide that by 2, leaving 3. So the prime factorization of 12 is 2 times 2 times 3, or 2 squared times 3. And let's look at 18, see what we got. 18 divides by 2, leaving 9. 9 divides by 3, and by 3 again. So both numbers yield a prime factorization composed of 2's and 3's, and every prime factorization is unique to its number. So 2, 2, 2, 3 will only ever yield 12 and no other number. And 18 is 2, 3, 3. So we've got a mix of 2's and 3's. So the rule is you need one of every number that appears, so we have both 2's and 3's. But we're going to go for the groups with the most numbers. So we'll take 2 3's from the 18, 2 2's from the 12, multiply those 4 numbers together to get our denominator that'll work for both numbers. So 2 times 2 is 4, times 3 is 12, times 3 is 36. And you may not have seen that, or you may have thought maybe it would work, but there will be times when you will have no idea what the lowest or least common multiple will be. So this is a really great method to use. Prime factorization, and then collect up the biggest number of the unique prime factors that you find. And they will always produce the least common multiple. Okay, so we're going to use 36 and do this. 36, something over 36 minus something over 36. And to get 12 up to 36, we multiply by 3. So 3 times 5, about 15. This is when your mad multiplication table skills come in. So we got 2 36 minus 15 36. Positive 2, negative 15. Signs are different. So we've got 13 is the difference, and the bigger number is negative, so 13 is also negative. Negative 13 over 36. Okay, I think we are almost there. 5, 6x is equal to this. How do we do the next step? Anyone remember? We're going to divide both sides by whatever is happening to the x. It's being multiplied by 5/6, so we're going to divide both sides by 5/6. And we write these a little bit differently. On this side, these are just going to cancel out. So same as a whole number, right? We're not even going to worry about doing math with nested fractions yet. That'll come up later. So this leaves x on the left, and that's equal to this expression. And with fractions, when you divide fractions, the magic phrase is invert and multiply. So if you turn a fraction upside down and multiply it, you're basically actually doing division. So here we go. 6 times negative 13, it's going to be a negative, but 6 times 10 is 60, and 6 times 3 is 18. 60 plus 18 is 78. And then you guys know my magic rule about multiplication by 5. Take half of the number, half of 36 is 18, and add a 0. It's a beautiful thing. So because it's late at night, and we're gonna just divide out by 2 and see how far it goes. So this gives us 39 over 90. Wow, and these are both divisible by 3. Cool. All right, I'm gonna run into, so I'm gonna rewrite it 39 over 90. We can take out a 3 twice. 39 divided by 3 is 13, right? 13. 90 divided by 3 is 30. And I think that's as far as we can go. So this is our x factor. X is equal to 13 over 30. And we should be able to plug this in up here and and that should be the right answer. So let's try it. 5/6 times 13 over 30 plus 5/12 is equal to 1/8. Right? 1/18. Sorry. Thanks, whoever shouted that out. That was helpful. So, when you multiply fractions together, it's kind of cool because you can pre-reduce, or preduce, as I like to say. Take out a 5, so 5 divided by 5 is 1, and 30 divided by 5 is 6. And now these numbers are a lot easier to multiply together. So we have 1 times 13, that's 13. Let me get some more paper. 13. And 6 times 6 is 36, plus 5 over 12, and that's supposed to be equal to 1/18. What do you think? Are we close? Let's see what we do. So to add fractions, add any numbers, any numbers in math, or subtract them. You got to have, something has to be similar. Scientific notation, logarithms, exponents, fractions, decimals, the columns have to line up. We're going to use 36 as our denominator. Multiply these both by 3, and we'll get 15 over 36 plus 13 over 36. Right? 13 plus 15 is 28 over 36. And I'm not seeing 1/18. We can reduce this to 14 over 18. So what happened? Is this a negative? Darn burn it, did I miss my... What was the original problem? We're so close. I just think, let's see if I can find it up here. I didn't fill in all my answers. Oh, yes, I did. Right, x. This one was negative 21, right? Negative 21. And then this guy, 5/6x. X was 13/30. Is that negative? By any chance? Negative times that. negative 78. So I did remember that. So I did forget the negative sign here. Okay. All right. So that should have been negative. So I apologize for that. And then if we put this in with a negative sign, so this is why you get if you can work quickly, you get an even higher grade by going back and checking. So here we have 1 times negative 13. X would be negative 13. So if we plan this, if we do this once more, we get negative 13, right, over 36, and negative 13 here, plus 15. So that changes this a little bit. So I knew I was stretching it to try and do 4 on 1 video. So negative 13, positive 15, the signs are different. So we end up with 2, and 15 is bigger than 13, and that has a positive sign. So we're talking about 2 over 36, and that does reduce to 1 over 18. Oh my goodness. Happy ending. All right, so that's already 15 minutes long, and that was 4 for the price of 1. So thanks for hanging with me, and I'll do these last 3. I'll try and fit them all on 1 video too. All right, I'm going to upload these and put them into Canvas, and you guys can get going.